All right, welcome back everyone to session number 3 on our Sysmac Studio training webinars. For those of you who sat through the first two, they were pretty basic and hopefully not too boring for you guys. Session number 3 today gets a little more interesting, a little more in-depth, so hopefully you guys will find this a little more mentally stimulating. On the agenda today, we have a little bit about the network browser feature that we discussed in session 1. So there are some gotchas with the network browser. There are some best practices, and there's also some troubleshooting tips that we're going to go over. And I've got a quick demo to show you guys with a couple different PLCs here, just to demonstrate the various connection options with the network browser. Then we're going to dive into Sysmac, and we're going to make a structure, or a UDT, they're commonly called, a complex data type. Then we're going to discuss something closely related to structures called offset types. Then we will get everybody to make their very first function block in your lift station project. Then we will add a library to our lift station project, and we'll show you guys how to import those and how to use them in your program. Then we're going to add a second pump to our lift station. And since we made our pump a function block in the previous exercise, it's going to be very quick and easy to do. Then we will have an exercise called tag mass manipulation using Excel. So this is a demo of how we can actually import different tag lists from different things. There might be an engineering document that you want to, shorten your development time by using. So we can actually use Excel to cut and paste directly from Sysmac and format it how we need. Then if we have time, we'll go over something called bit extraction. So this is how we will either read a bit or write to a bit within a different data type. So this is very relevant in a lot of different scenarios in a PLC. Okay, so the network browser, I mentioned this in session 1. Now what the network browser is a way for us to see what's connected to our computer as far as PLCs go. So in Sysmac Studio, if you are on the latest version, the network browser is located here. And we have a couple different options with the network browser.
Are you sharing your screen?
I thought. Okay, how's that?
Better.
Thanks. Okay, I'll back up a slide here. So yeah, with our network browser, we can discover PLCs with unknown IP addresses. It's a common use for it. I'm going to touch on how we troubleshoot common problems with the network browser and where we find both the tool itself and the configuration utility. So the tool itself is located in this directory here. So I've got it open over here. So in the communications middleware folder, if you're not on the latest version of Sysmac, you can access it in this folder here. If you are on the latest version of Sysmac, like you can see in the screenshot, there's a direct link to it right from the startup screen. So when we open it up, we have, excuse me, 4 different options to choose from here. So direct USB connection, if you are connected to one of our PLCs through USB, it will show up. Direct Ethernet connection, as the picture implies here. This is for when you don't know the IP address of something, you can connect a single cable, and it's important that it's just a single cable, between your computer and the PLC. So you can be on a completely different subnet. You can have DHCP enabled on your laptop, and the PLC will let you know its IP address, and then we can either get on the same subnet as it, or we can even program it without even joining its subnet. So Ethernet hub connection is when we need to go through network infrastructure, or if we're on the same subnet as the PLC, then that will show up. So a quick demo of what this looks like. So the first one I'll do is direct Ethernet connection. So my current IP address, and I'll just bring it up to show everyone here. So I am 192.168.250.123. So I should be able to talk to anything 192.168.250. But with direct Ethernet connection, and I'm just going to move my Ethernet cable over to a PLC that's on a completely different subnet here. There's currently a single cable between my laptop and my PLC. You saw my IP address. Now, if I browse with that single cable connected, I have discovered an NJ5 PLC, and it's 192.158. So a completely different subnet, completely different class of subnet, and I can pick it up. Now, if there was a switch in between my computer and this PLC, it's unlikely I would be able to see this PLC. It's just the protocol that we use and how we route that protocol. A lot of switches will block that. Now, Ethernet hub connection is when we're on the same subnet as the PLCs. So I'm going to go back into my switch now, where I have two PLCs that are on the same subnet as my laptop. And when I browse the Ethernet hub connection, you can see I've got two NX1P2s, and they're reporting their IP address. They're on the same subnet as me, which is why I can see them, and it's why I can talk to them through a switch. So the common use case for this is you find a PLC in the wild. You first see what its IP address is with the direct Ethernet connection. Now, you likely had to bring it off the network to do that. So once you have its IP, you can restore the network infrastructure. You can find an open port on a switch. You can put your laptop on the same subnet as it. And then we can just use the hub connection when we're trying to connect to that PLC. Now, the tool does not always work. I've had a lot of phone calls of people having some issues with it. So some common problems that we run into are no PLCs show up with the hub connection method. Now, this is usually when your PC is on a different subnet. The switch will not route the traffic properly, or it'll block the protocol altogether. Another common problem is no PLCs show up with the direct connection method. And this one, I just need to reiterate, it is one-to-one connection, so one Ethernet cable from the PLC to the laptop. And worst case scenario, no PLCs show up with either method. And this does happen sometimes. So when you install Sysmac, you may have noticed that there is a pop-up that looks something like this. I'll just open this up here. And this is the direct Ethernet connection setup utility, essentially. So this popped up when you installed Sysmac. A lot of people skip past it, and then it essentially disables it. But what you do with this, and it's also located in the same folder here, is you choose the interface that you want the direct connection utility to use. So it might default to Wi-Fi, and you might have clicked OK when you were installing Sysmac, and it's trying to do this out the Wi-Fi network, and that's probably not going to work. So you want to make sure that you have your Ethernet port selected, since that's what we usually connect to PLCs with. And we also want to make sure that it's enabled. So uncheck disabled, obviously. And failing that, the only other thing that I've seen interfere with this before is very strict security policies on laptops, or sometimes VPN software can interfere with the port itself. So any questions on the network browser and associated configuration software for it? Okay. So let's get everybody to open up their lift station project now, if you haven't already. So in Sysmac, we have something called structures, or UDTs. I'm missing a slide in there. That's all right. And when we go to make our own structures or our own UDTs, we can make them however we need. They might be for a very specific device like a VFD or some remote IO. And we can actually make a structure in Sysmac Studio to have the same data layout and format as a device that we're communicating with. We also might want to just make a UDT to make our life a little bit easier when we're programming. So if everyone can navigate to their PLC, and down in the programming section, there's a category under data called data types. So you have three options here: structures, unions, and enumerated data types. The last two are pretty uncommon. All we're going to be doing today is a structure, as they're by far the most common. And if you'll hold tight for 1 second, the slide I accidentally deleted has the structure layout that I'm going to be getting you guys to duplicate on yours. Okay, so we are going to create a structure for controlling a VFD. In the manual for the VFD, most devices that are network capable will have a data map in the manual for them. So this VFD example that we're using is from one of our MX2 VFDs, and it has something called a control word. And it's a lot easier to work with a control word if we create a structure out of it. So how we do that in Sysmac is from our structures window here, we can click and it will automatically add a new structure for us. So I'm going to name mine VFD control underscore word. Now when we want to add something to our structure, we simply right click on the parent structure and we can create a new member, and we can have as many members as we want. We can nest structures within structures. We can have arrays of nested structures. Can go several layers deep if we want to. For this, we're just going to have one parent structure with all of the VFD tags as members of that structure. So again, to add a member, we right click on the parent structure and we create a new member. So I'll put that slide up again that has the members of that structure in it, so you guys can copy that on your end. So give everyone a second to do that. And if you're having any issues, feel free to type it in chat or speak out. Does anyone need more time with that? Good. So now that we've made our own data type, when it comes time to actually use that data type, and you guys won't play along with this part, I'm going to be deleting this tag, but now when we create a variable, we can make it, instead of one of the elementary data types, we now have that VFD control word as a data type. So that means that in this case, the parent tag delete me has members delete me dot reset, etc. Everything that we've created in this structure can now be accessed by the parent tag dot member. So, and we will be coming back to this shortly for an exercise here, but that's how we create structures in Sysmac Studio. Now, something you may have noticed when we were making our structure is there's a column here called offset type. So we have a few different options for our offset type. We have NJ, CJ, and user. So when you look at this and you see there's less than 16 Booleans in this VFD control word structure, you would assume that this is going to take up less than 2 bytes or 1 word of data in your PLC. But structures are optimized to the architecture of the CPU. And we'll be doing an example to illustrate this shortly here. So what the offset type determines is essentially what the spacing is of all of this data. So currently we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 Booleans. So really we only need 10 bits, but if there's spacing in between every single member of this structure, it's going to take up a lot more than that. And now when it comes to something like communicating with a VFD, where these bits don't have any spacing in between them, we need to match them exactly where they reside in the data that we get. If we have spacing and the data we get doesn't have spacing, then the structure is not going to match up with our data. So the next exercise we're going to do is we're going to duplicate this VFD control word. So I'm going to rename this first one to underscore NJ, since that's the offset type by default. And then I'm just going to Control C, Control V to copy and paste it. And I'm going to call this second one user. So we're going to do one now with the user type of offset on it. Now, when we select user offset type, we actually need to tell Sysmac how to map this data. So there's a starting byte and a starting bit for our data. So I'm just going to fill in to make it as efficient as possible. So give everyone a second to copy that. So now that we've chosen the user offset type and we've explicitly stated where we want these bits and bytes to reside in our structure, we can now say with confidence that this is going to match the chunk of data that we get back from that VFD. Now, to illustrate why this is important, I'm just going to show you guys something on my end. You can play along if you want, but I'm going to, in my global variables, I'm going to make a data type, a variable, I should say, of each of those data types. So one for the NJ offset type, one for the user offset type, and I'm going to make them an input as the network publish, and this just lets us assess the size of it for Ethernet IP. And now when we have these two variables pulled up, you can see that the NJ offset type is actually 20 bytes in size, despite only containing 10 Booleans. So you can see there's a 16-bit spacing on those. And the one that we made, it rounded up to the nearest byte. So it's actually only 2 bytes in size. And since we're getting 2 bytes back from that drive, that's what we'll have to use. Did anyone have any questions on that? So whenever we're working with a structure internally and we don't have an explicit data map that we have to map that structure to, it's recommended to use NJ as it's optimized for the architecture. But if you have a very strict data map that you have to conform to, and this comes in common a lot when you're doing networking, user is what we have to allow you to match that data map bit for bit kind of thing. Okay, custom function blocks. So if you're familiar with other platforms, these are sometimes called AOIs. They're fairly similar to a subroutine in a text-based programming language. But essentially, when we make a custom function block, it lets us create some code and then reuse it indefinitely to have identical duplicate instances of this code running in your PLC. So we can make custom functions or custom function blocks. Really, the only difference between them is you use a function block when you need to retain something for the next scan cycle. So it will allocate memory that it keeps for that function block. Functions, on the other hand, don't need to retain anything for sequential scans. So if you were doing a simple math operation, spitting out the result, that could be a function. If there were timers and counters involved, you would want that to be a function block so that we could keep those values in memory. Now, they are online edit friendly, which is a very nice feature. So when we edit our function blocks, we edit the base instance of our function block, and that change is duplicated on every instance of the function block on the next scan cycle. So we will be doing an example of an online edit on our function blocks once we have them in our project. We can also incorporate structures into our function blocks, and we can even have one function block consume only one single variable that is a structure, and everything related to that function block can use a single variable. An HMI could have an IAG that uses that same variable, and it can aid in very rapid development of duplicate type code. Now we're going to make a function block for our lift station motor. So our inputs are going to be start, reset, and fault. And the outputs will be the run command to start the motor, the fault alarm, and also how many hours that motor's been running for. So in Sysmac Studio, there's a section in our programming section of the Multi-View Explorer called Functions and Function Blocks, and I'll play along with you guys on this one. So in programming, under POUs, we have functions and function blocks. So if we right-click on function blocks, we can add a ladder or structured text function block. So we'll add a ladder function block for this. And it gives it a name, function block 0 by default. So we can right-click on it and rename it motor underscore control. And when we double click on motor control, the programming environment looks very similar to our standard ladder logic programming environment. And as from a programming standpoint, it is. We have all the same functions and function blocks available to us. All the hotkeys and branching that we did in our programming environment is going to be identical in our function block programming environment. But the big difference is our variables tab up here at the top. This is going to be different than what we have available to us. So in our normal programming environment, we have internals and globals. When we're working with function blocks, we have internals and externals, just like we do in the programming environment, but we have another category here called in/out. So in/out variables are variables that are going to be visible when you have your function block in your ladder logic. So from the PowerPoint, I mentioned that we will have 3 inputs and 2 outputs. So when we're configuring our function block, we will actually choose what that variable is. Is it an input or is it an output? There's also a category called in/out, which is essentially both an input and an output. We can read from it, we can write to it, and obviously we have to take precautions that we don't mess up the data integrity when we're doing that. So things like arrays and structures have to be in/out variables, but for elementary data types, input and output is all we need to use for that. So to add a variable in our in/out category, we just right click and we can create a new one. So I'll get everyone to create the variables that I have on the PowerPoint here. And you're also going to choose the in/out type that I have displayed here. And I will be playing along on my other monitor here. So if you're having any issues or you have any questions, feel free to type it in chat or speak out. I should add, there are some internal variables once you get down to the logic, like the timer reset and the hour timer, accumulation timer block. So you can just create those as internals, and it will prompt you if you want to do that. Another thing worth noting here is that the runtime hours, the very last variable that I have here, does have the retain check mark checked off on it. That's going to be our hour counter, and we want to retain that through power loss. And if anybody's wondering where you get the accumulation timer function block from, it's in the timer category in your toolbox. Is anybody having any issues, or does anyone need more time? Good. So in the example, I believe there was 1 minute as the time on this, and this is just the first thing that we're going to do, just because it's easier to wait a minute than an hour for your timer when you're testing it. So it's something that we'll be going back and changing with an online edit once we're comfortable with our accumulation timer logic here. Now, when we put this block into our ladder logic, the order of the input and output variables will be the same order that they appear on the function block itself. So top left will be start motor, then reset, then fault. On the right-hand side at the top will be our run command, then our fault alarm, then our runtime hours. So I'll get everyone to go to their main control program now. And down where we have our tank level logic starting our motor here is essentially where we're going to inject our new function block here. So I'll get everyone to add a rung after rung number 4, if that's where you have it on yours. And if we right click on our new rung, we can insert a function block, or we can press F. And when we type the name of the function block, that's going to pick the function block that it will drop in there. Now we named our function block motor control. So if we start typing motor control, it should detect it. And now we can see all of the inputs on the left-hand side that we created, all of the outputs on the right-hand side that we created. But since this is a function block, we need to give it a name. So I'm just going to call this pump1 function block. You guys can call yours whatever you want. Is anybody having any issues adding their function block to their logic? Okay, so now since we programmed this one way, and now we've made a function block to remove the motor control from the program, we're going to do some modifications to our program so that everything goes into our motor control function block. So when we're using our level to start the motor, I'm going to actually change this to high water level, like that, a global variable. And we'll also change that tag down below. And then we can map that high water level tag directly to our function block's start motor input. For the reset input, we can map our reset push button directly to our function block. And the fault input, we can map our fault input directly to our function block as well. For the run command, we're going to put our start motor output on that rung. For our fault alarm, we're going to map the motor underscore alarm bit to that. And for our runtime hours, we're going to create a variable for that. So we'll just call this pump 1 hours, and we'll make that a global variable. And now we can delete the logic for, actually, we'll leave that logic alone since that's what's shutting down our run mode. So we'll leave that logic, but we can strip the motor alarm logic out of rung 7 now, since that's handled internally in our function block. Same with the resetting logic for it. Now, this exercise in reality for this particular lift station was probably more trouble than it was worth, but where this comes in handy is if you had multiple pumps or multiple lift stations, you can program the entire pump logic on one rung of code, and it's all done internally from your counters to your fault handling to your resetting, etc. So we will come back to this function block, but I'll get everyone to start their simulator, unless, does anyone need more time? Okay, so everyone can start their simulator then. Okay, so with your simulator fired up, we can just flip the high water level bit true, since we're not in run mode, so this logic is essentially bypassed, but we can flip our high water level input true, and that has turned on the start motor input to our function block. And if we want to look at the particular logic within an instance of a function block, we can right click on that function block and we can go to the very bottom of the list. It says to lower layer, and that will bring up the logic of that particular function block. So if we had multiple instances of this, we could drill down to the logic for each instance of them. If one of them was acting differently than the rest, we could troubleshoot that function block specifically. Now, I mentioned earlier that we can do online edits to our function block, both in the simulator and on a live PLC. So what I'll get everyone to do is right-click on any of the rungs that you see, the rung numbers in your function block, and we'll go down to Online Edit, Start. And if you haven't made your function block 1 minute, you might have made it 1 hour, since the timer is called 1 hour, but we don't want to sit here for an hour waiting for our timer to roll over. So if you haven't made it 1 minute, you can make it a 1 minute timer for now. And I'll get everyone to just add a variable to ET so we can see what the elapsed time is. And it's going to make it as an internal by default in an online edit. And once you've done that, you can right click on any one of the rung numbers. You can go to Online Edit, Transfer. And now every instance of this function block has this updated logic running inside of it. So now we can see what our timer is at. And if yours was set to a minute, you should have accumulated some hours by now. And if you're happy with the way your logic is operating, I'm going to switch my timer back to 1 hour since I've verified its functionality. So I'm going to do another online edit and I'm going to make my 1 minute timer set point back to 1 hour. So I'm just going to change the M to an H and now it's a 1 hour timer since we verified its functionality. Saved us some time. So we'll send that final change to our function block. And the next time this rolls over, it's going to be a 1 hour timer. Now we're not going to test the full functionality of the function block just to keep things progressing. We've got a fairly full schedule today. Was anybody having any issues with that simulation, drilling down into the function block, doing the online edits? Oh, Pratiksha had a question on rung 3 in the function block. So that is a good question. So the way I did it is I started with an output. Let me make a new rung just to illustrate it a bit better. So when you're paralleling an output like this, if you start with two outputs first, then you can put your add logic in there, and then you can simply delete the other one. If you try to do the paralleling like you normally do with a function or a function block, it doesn't always branch it. So I generally lay it out with outputs first, and then I insert the other output instructions that are Boolean. And if you ever change your mind on an online edit, you can cancel it, and it will just go back to the way you had it. Good, so I'm going to stop my simulator now. So that's how we make a function block. Now there's something in Sysmac called libraries. So Omron provides a large number of libraries for our products for special applications. For example, if you're looking at some of our servo drives, we have a servo press library that's got a lot of the programming done for you. They generally consist of PLC code and HMI objects, which we call IAGs. Now, we can make our own libraries and IAGs. A lot of customers like to do this to have a standardized set of objects that they program their PLCs with that all of their programmers are familiar with. Now, we can make our own or we can import pre-made ones. So in the student material folder, just pull it up here. So there is, for session 3, something called traininglibrary.slr. It should be in the student material folder. Mine is, for some reason, thinking it's a PDF, but doesn't really matter. Now, in Sysmac Studio, make sure your simulator's stopped. We go up to Project, Library, and Show References. Now, these are the libraries that our project can reference. So there can be multiples in here if we want. And if we click on the plus sign in the bottom left to create a reference, then it is going to get us to drill down to that folder that was in the student material for session 3. And we will pick the traininglibrary.slr. And you can expand it and see exactly what's inside of it if you want to. You can see there's a function block inside of this training library, and it gives you the tags that are in this function block. So you can kind of preview it before you import it. But once you've selected that, you're going to hit OK. And now in your toolbox, when you're in your ladder logic programming environment, there's a category called training library. Now, when you make your libraries, you can choose what category they fall into. So if you had a modified analog conversion function block and you wanted it to fall into the analog conversion category of your library, you could do that. So what I'll get everyone to do is to go into the analog program where we set up our scale trans block. And we will drag the analog sim function block from the training library category, and we'll drop it to the left of the scale trans block. Since it's a function block, we'll have to give it a name. And we can delete the tank level raw into real conversion now. And on the output of this function block, there is an output called sim underscore value, and that'll be our simulated value. So we're going to take this tank level real. I'm just going to copy and paste mine, and that will get its value now from this function block. So what this function block is it just simulates a fluctuating tank level so that we can watch our plant turn the pumps on and off on its own. So it does have some inputs here. So we want simulate on all the time. So we can just have the rung going directly to simulate. Sim max and sim min have default values internally. So we don't want to overwrite those. But if you wanted to change the minimum and maximum values that you were simulating, you could, but you don't need to. And they're configured for this training essentially. So don't put any variables or constants on the sim min or sim max. So everyone can fire their simulator back up once they've done this. So once your simulator is running, you should see a simulated tank level changing. So the idea with this is you can start your simulator, start your plant, give yourself some set points, and your pumps will turn on and off as this tank level fluctuates. If you're curious what's inside of the analog sim block, I did not lock it, so you can go to the lower layer. It's basically just a moving average with a couple index arrays to pull from. Not really part of the content, but if you're ever curious, you're more than welcome to drill into that function block and see how that's all done. Is anybody having any issues with the analog sim library?
Nothing's changing for me.
It does take a few seconds to kick in. In your simulation, at the bottom right-hand corner of your screen, there is a speed control for your simulator. Is it all the way up to normal?
Yes.
Okay. If you see where my mouse is here, is program 0 checked off in the tasks here on the bottom left where my mouse is?
It is not.
Okay. Yeah, sometimes if you accidentally
there it
uncheck
is.
that, it's gonna pull it out of the tasks that it's running. So,
It's on now.
okay, good. Yeah, but you guys can see what it's doing. You simulated your plants before. Now, what this simulator block is going to do is eliminate the need for us to change this tank level raw every time we want our plant to do something. So You're welcome to play around with that after if you'd like. For now, though, we will stop our simulators. It sounds like everybody's simulation was working and the simulated values were getting into their project. So those are libraries. And like I said, you can make your own libraries. You can have version control on your libraries. You can lock your libraries if you don't want the code visible to the end user. So if intellectual property is a concern for some parts of your project and not others, we can actually lock function blocks down so that they are impossible to get the code out of. Any questions on libraries before we move on? Now, I should add, that was probably the world's simplest library. We can freely copy and paste between multiple instances of Sysmac Studio. So for some people, it might be more convenient to just have a project with the code that you wanted, and we can just copy and paste that function block right out from one and into the other. So the next exercise we will be working on is called tag mass manipulation using Excel. So one thing in Sysmac that we can do is we can freely copy and paste from Excel into Sysmac. So in the student material folder, let's find mine here. So there is a folder for session 3 called tag exercise. In there is something called device list. So I'll get everyone to open up the device list spreadsheet. Now we could do this in a project of its own if we wanted to, or a PLC of its own if we wanted to. So if you'd prefer to do that and not to add these tags to your lift station, since we won't actually be using them in the lift station, you're more than welcome to add a PLC to your project and have these kind of on their own. But I'm going to add mine to the lift station PLC just to keep things moving smoothly here. So once everyone has the spreadsheet open, you can see here, this is just a spoofed engineering document of an instrument list with ranges and comments. So when we copy and paste to and from Sysmac, there is a specific format that we need to follow, but it's very easy to mimic that format within Excel. But generally the first thing we need, though, is an example of that format. So in Sysmac, if we go to our global variables, so in data, we go to our global variables, we can grab any real tag, and we're going to click to the left of it, not on the name, not on the data type, to the actual left of it, the gray rectangle. So if we right click there and choose copy, we can paste that tag directly into Excel, and that will give us an example of the format that we need. So I'll paste this into Excel. And now we can kind of rework this spreadsheet to that format. So I'll let everybody, you might have your own way of doing things in Excel. I'm just going to kind of copy and paste all of the instrument names. And then the data type, I'm going to duplicate on all of these. The location, I'm going to make my comment. And the ones that are true and false here, these are retained and constant attributes from our tag list. So they don't need to be retained. So I'm going to change that to false on the ones that I want to import. So I'll give everyone a second to do that.
Yeah, Stuart, I think in your column G there, I think you want to move those descriptions into column H.
You are correct. My
Yeah.
column G was too small.
Okay.
So yes. Good observation. Yeah, so our column G will make do not publish on everything, and H is actually our comment. So thanks. So when you're done that, we will select essentially from the very top left of the new data we created to the very bottom right, which is the last comment of the last variable. We will select all of those boxes, and then we can copy those and paste them directly into our global variables. And you can see they are added with the comments we specified, the data types we specified, all the attributes that we looked at in Excel should all be pasted correctly into Sysmac like this. This is handy when you've got engineering documents like tag lists that you want to follow or a shutdown key, something like that. You can even use some of the tools in Excel to aid with tag naming when you have a lot of similar tag names with prefixes or suffixes. There's some tools in Excel you can use to even generate tags for you. You can take advantage of those. So did everybody get their tags to paste back into Sysmac properly? Now, some of you may have grabbed the example tag that you pasted when you did your copying and pasting from Excel. And that's fine. If Sysmac detects any duplicates, I'll just repeat this. If Sysmac detects any duplicate tags, it will bring up this resolve pasting conflicts page. So it will actually tell you the variables that you're trying to paste into it, and it will tell you any conflicts. And then you can choose to, pick one or two of them out, or you can just copy them all into your project, that kind of thing. So occasionally there might be some duplicates in there, and it will warn you about those before you paste all the new tags into your project. Did anyone need more time with that or have any questions on that? Good, short bunch.
It's not letting me paste anything. It's like grayed out for me for some reason.
So where are you trying to paste it in Sysmac? Are you
Just
trying to pick? No, I'll let you finish. Go ahead.
oh sorry. Under the high, like the HI. Yeah, it was just I was clicking on the box to the left of that.
Try clicking where there aren't any variables. So at the very bottom of the list, does that have it as an option for you?
Still grayed out.
Still grayed out. In Excel, did you? Yeah, try reselecting everything in Excel and recopying. I've never encountered that.
Yeah, it doesn't seem to want to let me paste still.
Interesting. Do you have administrator rights on your computer?
Oh, I think I launched it with that, but I'll maybe just double check that I launched it with admin rights.
Make sure you save if you're
Yeah.
planning on closing it. Yeah.
Thanks. I'll try that.
Yeah, try it. This isn't critical to anything else we'll be doing today. This is just a simple exercise. So if it's not working for you, I'm going to assume it's something to do with administrator rights. I've never seen that before, but okay. So bit interrogation or bit extraction, it's sometimes called, which is essentially you have a variable, let's call it an integer, and you want to know what the fifth bit is, whether it's a 1 or a 0. So in some platforms, we can drill down to it by specifying the tag name dot 3 if we wanted the third bit. Or should be the fourth bit, bit number 3. Now in Sysmac, and this is actually the way IEC 611 prefers you do it, that is not a supported format for interrogating a bit within a variable. So in Sysmac, we have basically two ways of doing this. We can use something called a union, which works with words, bytes, and bits, which isn't always the case. But we do have something in Sysmac called the AT column, which we talked a little bit about. And we can actually use the AT column to assign addresses to variables. And when we assign the same address to multiple variables, the bits within those variables will be duplicated across whichever variables have the overlapping addresses. So this will be more clear once we actually do a demo of this here. So normally in an address-based platform, you avoid overlapping addresses or duplicating them. But we can actually use this to our advantage in a situation like this. And it doesn't only work for bits. We can actually use this to duplicate the contents of variables bit for bit if we wanted to. We're just going to keep this kind of short and sweet and the most common use case for it. So in Sysmac, the memory feature is turned off by default. But if we go into our controller setup in the Multi-View Explorer, then we go to memory settings, we have all of the different memory address banks that we have had over the years. So if you've programmed any of our C-series PLCs in CX Program or something like that, these probably look familiar to you. So what we'll do is we will check off the WR memory, the work memory, it used to be called. And that will enable us to assign W addresses to variables if we want to. So again, that's in configurations and setup, controller setup, memory settings, and we'll check off the WR registers. Now defaults to 512, which is far more than we'll need for this, but now in our global variables, I'll get everybody to go to their global variables, and we will create two new variables. Now, the first one is going to be a status word, we'll call it. And the data type will be word. And the second variable will be status bits. And the data type for this will be an array of 16 booleans. So you can type bool and then square brackets 16. That will create an array of 15 booleans for you. Okay, is anybody having any issues? Need more time? Okay, now in the at column, the AT column, now we can assign one of those W addresses that we enabled. And the syntax for that is percent, and then the memory bank, which is W, and then the address. So I will just pick percent %W1 on my status bits, and then I'll put that same address on my status word, percent %W1. And now these two variables are linked by this address. And if I change the value of the status word, the status bits will reflect the Boolean equivalent of that, and vice versa. If I wanted to go the other way and I wanted to convert an array of Booleans into a word value, I could flip bits in this word, or in this bool array, sorry, and the word will reflect that value. So we can do this in the simulator, and it's going to give us the same result as it would in a PLC. And we can use our watch windows to play around with this. So I'll get everyone to fire their simulator back up. Okay, now if you don't have any of your watch windows open, you can go up to View, Watch Tab Page, and you're also going to go up to View, Watch Tab Page Table, and that will open both of them. So the Watch Tab Page Table is for arrays and structures. The Watch Tab Page is for elementary data types. Now, since our word is an elementary data type and our bool array is an array, we're going to use both of these here. So in our watch table, that will be our array. So we can type the status bits as our tag. And we can see all 16 bits in their current state. And in the watch tab, we can delete tank level raw, or you can add a new variable, it doesn't matter. And this one will put our status word in. And now, since this is a word, we modify it with hex values. So if I do 0f, 0f, hit enter, and I look at the bits within that word in the watch tab table, you'll see the binary equivalent of 0f, 0f in Boolean. So in logic, you could assign an address to an alarm word, for example. That's a common application for this. It comes in over Modbus as a word. It has bits that indicate specific alarm conditions in it. And we can have a rung below it where we take those bits and we map them to the alarm bits that are required. And if you want to go the other way, we can flip bits within our bool array by modifying them. And we can see now when we look at the word, what that value is in our online value. So I'll give everyone a second to play with that, flip some bits, see what some hexadecimal values are in Boolean. And if anybody's having any issues, now would be a good time to speak up. And if you're curious what 1010 repeated is, I'm figuring that out now. The hex value for that would be 5555. So, okay, if everybody's got that working, you can stop your simulator now. So that's very useful for converting words into bits and vice versa, but we can also use that for structures. So if we go back to our UDT example here, where we created a structure and we had a chunk of data coming from a drive on the network, for example, I could actually take this word that's coming from the VFD, give it an address, give my VFD control word. It would have to have the user offset, not the NJ offset, but I could give them the same addresses and that would do the exact same thing. Creating a structure and assigning that data type initially just kind of cuts down on that extra step, but you don't always have that option with all of communication protocols that we support. So good. So we have time for one last exercise here. So in our main control routine, we added our custom function block to start our motor. So in our scenario here, we are going to pretend that this plant was undersized and more houses were now feeding into this tank, and we actually had to add a second pump that would run in unison with it. So this is where creating your own function blocks can save you a lot of time for future development. So we're going to add a rung below rung number 5, where we had our motor control function block. And we are going to put another motor control function block there for our second pump. So you can type F as the hotkey for a function block, type motor control, and this will be the pump 2 function block. Now in our EtherCAT network, we will need to add cards onto this for the IO points. So for now, we're just going to create the tags as global variables. But if we wanted to copy and paste this EtherCAT coupler, copy and paste the tags associated with it, we could very easily add them. But for the purpose of simulation, we're just going to create global variables that we can map in the future to our second pump. So high water level will be the same on our input. Everything else will have a pump 2 suffix on the tag. P2 to keep things short. Now, another tool that we can use to speed up our development, now that we have this tagged with a 2 in all of these tags, and you guys can play along with this or not, it doesn't matter. If we added a new rung and we do something called a search and replace, so Control F brings up your search and replace. So if I had a pump 3 that I wanted to add, I could search for the letter 2, the number 2, and I could replace it with the number 3. And I would look in my selection, since I have this rung selected, and I could search and replace everything with a 2 in it. And now everything has a 3 in it. So I essentially added a pump and all of the logic for it in about 15 seconds there. Now we'd still need to go and create these variables, but that's a fairly quick process. So I'm going to delete that rung. That was just an example, but if you want to go to search and replace a different way, you can get there from I don't usually use this way. Let me check.
It's in edit.
Edit, search and replace. There it is. Thanks. But yeah, Control F or edit, search and replace will bring that up. If you guys want to simulate your second pump now, we have time. If you have general questions or issues, now would be a good time to bring them up. I'm going to hang out on the call until the half-hour mark here. We are done the content, so feel free to play around with your simulator, drill into the new function block. And if your project's working, feel free to jump off. If you're having any issues, I'll be on the call for a while, and we'll see you on the next one.